Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 14 February 2023. The problem statement for today is walls coloring. This problem is based on dynamic programming. Let's now open this problem. So first, we will go through this problem clearly. This problem says there is a row of n walls in Greek land. The king of Greek land ordered Alexa to color all the walls on the occasion of New Year. Alexa can color each wall either pink, black or yellow. The cost associated with coloring each wall with a particular color is represented by a 2D array color of size n into 3 where color of I0, color of I1 and color of I2 is the cost of painting ith wall with pink, black and yellow respectively. Okay, so here in the question it is saying that we need to color the walls there and the cost for painting each wall. The cost is given in this matrix, 2D matrix, where color I0 represents the cost for painting in pink. That means here if we look at this example, then 14 is the cost for painting the wall in pink color. I1, colors I1, this is the cost for painting the wall in black color, and color I2, this is the cost for painting the wall in yellow color. So similarly for as many walls we have been given three alternatives to paint it either with pink, black and yellow color. And here what we need to find, you need to find the minimum cost to color all the walls such that no two adjacent walls have the same color. Okay, so we need to color it in such a way that means no two walls have same color, that means two adjacent walls have the same color. If you try to recall, then this problem is similar to what we have earlier also, which is this problem, distinct coloring. So here also the problem, it was similar to that only. Here we need to paint houses, and for this here also the cost was given in for painting it in red, green and blue. So we had to paint it with these three colors, and here also same condition was there that no two adjacent houses would have the same color. So the way we had solved this question, we will again solve this question, this question of wall coloring, because here again we will be using the concept of dynamic programming. So before start writing the code, let's first solve it on this editor. So we will take this example only just to understand this one. So here it is saying with this example which n is equal to 3, this is the cost matrix for painting it in three different colors. So here the options it is given as 14, 2, 11, 11, 14, 5 and 14, 3 and 10. So if you are painting the first wall with pink color, then the cost is 14, with black it is 2, with yellow it is 11 as we have seen earlier. For painting the second wall, the cost for painting it in pink it is 11, for black it is 14 and for painting in yellow it is 5. For painting the third wall in pink it is 14 again, black it is 3 and painting in yellow it is 10. So using these three combination we need to see that what combination of colors we need to select so that we can paint it in the minimum cost. So when we say that we will be using dynamic programming for solving this, then what happens in dynamic programming is that we try to solve smaller problems, thus resulting in solving that bigger ones. So here also we will be doing the same thing. Before writing here anything, just let's go through the explanation here. Here it is saying that color wall 0 with black, that means it is saying that color first wall with black, the cost will be 2, next wall with yellow, the cost will be 5, and again next wall with black again, so it will be 3. So the minimum cost for painting these three walls, it will be 2 plus 5 plus 3 is equal to 10. So here in this editor we'll see how we have approached to this solution 10. That means how now this is simply it is written here. We can directly see with our naked out that this is the minimum, then 5 is minimum and 3 is here. So we can take all the things, but writing it programmatically we need to check that which is the previous minimum value that we need to consider to add it to the current value. So for that let's suppose, so here if we are taking this as our input only, this is the first combination which we are choosing. That means if we are painting the first wall with pink only, then the charges will be 14. If we decide to paint it with black, then it will be 2. If we try to paint it in yellow, then the charges will be 11. So these are the 3 combinations which we have for painting the first wall. But when we go to the next wall, that see we have to paint all 3 walls. So if we have to paint only one wall, then we can clearly say yes, the 2 is the minimum cost, so we will paint it with black, and then just at that point only our task is done. But we need to paint all 3 walls. So if for the second wall, if we decide to paint it with pink color, so what is the charge for that? Charge for that is 11. So it will be 11 plus what was the minimum charge for painting the first wall. Right now we are talking about painting the second wall. So what was the minimum charge that incurred for painting the first wall? So that will be minimum of these 2 number. Why we are saying minimum of these 2 number? Because here we have condition that no 2 adjacent walls should have the same color. So if we have painted the first wall in pink, so we cannot paint that wall again in pink. That's why we will be taking minimum of these 2. Minimum of 2 and 11 is 2. So it will be 2 here. Next one, if I decide to paint it in black, if I decide to paint second wall in black, so 14. What were the minimum charges for painting the first wall? So that will be minimum of these 2, 14 and 11. So minimum is 11. But if I decide to paint it in yellow, so the charges will be 5, because here the charge for painting a wall for a second wall, if you are opting for that solution, the charge for painting the wall in yellow is 5. To this we will be again checking what was the minimum charge incurred to paint the first wall. So that will be again minimum of 2 and 14. Here again the same reason, we are not considering this one because we cannot have 2 walls painted in the same color, 2 consecutive walls painted in the same color. So here if I just write a summation of all this, so the array would become, let me just expand it. So here it will be like 13, it will be 25, here it will be 7. So now let's get this removed so that we have a clear picture. So till this point we have painted 2 walls. So here we can see till this point the minimum, see if our problem was up to this only, then we can clearly see that till this point, once we reached this location, then we can say that both of our walls have been painted. And what is the minimum charge? Minimum charge is 7, which was 5 for current one and 2 from the previous one. So that how we got 7. But in this particular problem we have another wall. So here also we will take the same approach. Here if I again try to paint it in pink, so the charge is 14 plus minimum of these 2. What are these 2? The minimum cost that was charged for painting the rest of the 2 walls. So the minimum between 25 and 7, it is 7. So we'll just take that 7 here. But if I decided to paint it with black, so the current cost for painting the third wall in black, that is 3. To this we will add the minimum charge that incurred for painting other 2 walls. So that would be minimum of 13 and 7. Minimum of 13 and 7 is 7. So we'll take 7. And if I decide to paint the third wall in yellow color, so the charges is 10 for that. And what was the minimum cost to paint other two walls? That was charged for painting other two walls. So that would be again minimum of 13 and 25. The minimum of 13 and 25 is 13. So here we will get 21, 10, and it is 23. If we get this removed, so here in the last row we have got all the combinations, the different solutions. If we have different solutions, we have to paint it in either in yellow, pink, black or yellow. So here we can see if we decide to paint third wall in black color and the second wall in yellow color and first wall in black color again, then we see the minimum charge we have got is 10. That only is the solution. Sorry guys. So this is the only solution. So whatever we have discussed here in this editor, the same we will try to code. I'll be providing the link of that previous question that we saw about distinct coloring in the description box. So kindly check that. So now let's go to our GeeksForGeeks portal and let's try coding for this. So here whatever we have done in this editor, we will just code for that with similar approach. So now let's minimize this. So now let's start coding for this. So first we will create a double dimensional array calling dp, and that will be of type integer, and here the size will be number of walls we need, and we have three different color combinations, so int of n of 3. So now for the first one, see what we had done here. For the first iteration, what we did, we chose whatever was given in the first option in the array. So we are choosing that only as the first option, and for the rest of the walls we chose minimum of the previous ones. So here also, if you had only one wall to paint, then what we had to do, we had to check what was the minimum cost out of these three. So that only we'll do here. So first we'll initialize dp of 0 0 with colors, I hope I've written the spelling correct, okay, colors of 0 0. So now we will copy it thrice. I will just change the row and column number. So here Control C, I'll just Control V and Control V. So now second one, for the second column, here again we are taking the second option. For the third one we are taking the third option. So till this, what we have done, we have just did this one. That means whatever was there in the first options, that means the choices of coloring the wall, that only we have taken our first solution for painting the first wall. If there was only one wall, then we had to take the minimum of these three. So we have just opted, tried breaking it down to one wall and just tried to figure out what was the minimum combination for that. So for that we got these three options, 14, 2 and 11. So that only I have initialized in this array with as it is value with dp of 0 0 is equal to with color of 0 0, dp of 0 1 and with color of 0 1, dp of 0 2 with colors of 0 2. Now to this we will run a for loop to get other combinations. Int I of, here we will be starting with 1 because we have already taken our base scenario there, that means for a first wall. So we will be starting with the second wall. and it will go up to n, the number of walls we have been given, and plus plus. So here now what we have to do here, we have to dynamically assign values for each wall. So here if it I of dp of I and 0, that means in each iteration we will be first filling this one, dp of I0, then dp of I1 and dp of I2. Similarly it will be for dp of I0, dp of I1, dp of I2. So dp of I0, what it will be? It will be the charges for painting that particular wall in that particular present color. So it will be I of 0. So color I0, color I0 here starting with the 1. So what is the color of 10? Color of 10 is 11. So right now we are taking this one in consideration. So to this we need to add the previous one, as we had seen here. To this we added this 2 and this, the minimum of 2 and 11, which was 2. So we added 11 and 2, that we got 13. So that only we are doing here. To this I'll add, to this only I'll add math.min of dp of I minus 1 and 1 comma dp of I minus 1 comma 2. So here what I've done here is that to this one, how we got 13? To 11 we added minimum of 2 and 11. So minimum of 2 and 11 was 2. So to get, currently we are in this one. So how to go to minimum of 2 and 11? So we need to go one row back. So that's why I did the here I minus 1 in both the scenario. And what we need to refer? We need to refer column number 1 and column number 2. We cannot take column number 0 because again the two adjacent walls will have the same color. So once this is done, so right now we have got the value 13 here. 13 means this value. After this operation we will get this value 13 here, because we have already taken the current value plus minimum of these two. So now I'll repeat this one 3 times and I'll just change the index values. So here it will be 1 and here also it will be 1, and here also we need to get to the previous row, so it will be always I minus 1. But since we are in the middle row means 14, this one we are referring to this one, so we have to take the minimum of the this 0th column and second column. So for that only I'll do here column 0 and column 2. And for third one, this one here, if you are in this one, if you are at this location, that means in the column 2, if you are in the column 2 at any point, then we have to look at the previous minimum of these two values. Minimum of these two values means, that means not exactly that. Here if you are at any point, we are at this point 7 or 23, if you are filling this one, then we have to look at the minimum of the values which we have got in column 0 and column 1. So that only I'll do here I minus 1, that will, it will take us to one row backward, and column will be 0 and here column will be 1. So when this loop will be completed, then we will get this entire 2D array. in as it is form, that whatever we have got here, it will be similar in that format only. So what we need to do now, so once we got this one, then our option is, our solution will be simple. Now we have to just check that once the iteration is completed, that means whatever we have got in the last array, that means we have painted all the walls, what is the minimum value in that array? So minimum value is 10 here, so we will just try to find that only, that how we will take the minimum one from the last one, from the last array. So for that I'll take math.min again, math.min. Again I need to do math.min, and from this I'll check dp of math.min here, and to put bracket here, yeah, here dp of n minus 1. See, because here it is n is 3, but it will only go if we look at double dimensional array, so the row number will be 0, 1 and 2. So just taking through the last row, it will be n minus 1. So now here will be, what we will be doing, we will just check which column has the lowest value. We will check whether it is of 0 or else math.min of, here we need to pass again, let's copy this part, control C, control V, or it will be column 1, or whatever we get out of these two. See, because math.min can accept only two parameters, so first I'm checking with column 0 and column 1. If it is not the case, then dp of column 2. So what we are doing in this last statement, math.min of first these two, that means whatever we have got in last row, column 0 and column 1, minimum of column 0 and column 1, that here we will get 10. Then the resultant of these two with this one. So here in the second step it will be the math.min of 10 and 23, which is again 10. So here please put a semicolon. So here only we have done 0, 1 and 2, minimum of all these things, and here I need to return the cost only. So I'll just type here return. I think I'm pretty well done with my coding, so I'll just try compiling this. See, this question is almost 90% similar to the previous one, the distinct coloring question. I think I missed something. Okay, oh my bad. This bracket has to be here. I need to first close the for loop, then I need to calculate this minimum operation. Okay. Yeah, so what I was saying, that this question is almost 90% similar to the distinct coloring option, but only here it is in more sorted way, because the colors, the input has been given in that way. Yeah, but we are following the similar approach, and we are first solving the problem for one wall, two wall, and finally reaching to the n walls. So here we can see we have got our output. Now let's try submitting the solution. Okay, so here we can see we have got all the test cases covered. So we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.